Hello, everyone. Thank you for joining us today for In Situ Soil Blending webinar with our speaker, Brantley Rudd with Exo Tech. I'm Ashley Swingle, Marketing Specialist with Carus. A few housekeeping items before we get started today. We are recording this meeting and everyone is kept in listen-only mode. If you have any questions, we encourage you to submit those throughout the presentation using the question pane in the GoToWebinar panel or email us directly. If you submit questions through GoToWebinar, we will receive a report with the question and your contact info to follow up directly after the webinar. If you're interested in receiving a PDF or recording of the presentation, please contact us. We encourage you to share the recording within your network. Here are a few ways to find us. We have listed our website and general sales and marketing email address, as well as my email address. Do you receive our email blasts for upcoming webinars, presentations, trade shows, and technical information on our various solutions? If not, sign up on our website. You can find the Join Our Email list on any landing page on the right-hand side. Also be sure to select the industry when signing up to ensure you receive the most targeted information for your needs. And we can't forget to mention our social media platforms. We encourage you to connect with our Carus page as well as our team members on LinkedIn, where we are often sharing upcoming events, including webinars, industry article news, or sharing relevant posts from other industry experts. Listed here are links you can visit for upcoming webinars and also our website. At this time, I would like to take the opportunity to introduce our speaker, Mr. Brantley Rudd. Brantley has been in the environmental field for over 18 years. His experience ranges from phase 1 site assessments to multi-phase remedial plans. He has currently been with Exo Tech for over 12 years and has designed and implemented remediation plans throughout the Southeast. He has designed and implemented remediation plans as simple as a small surfactant injection to large in situ blending projects. Brantley first got into the environmental industry working for an environmental consulting firm operating a dual-purpose drill rig and assisted on phase 1, 2, 3 property assessments, RCRA investigations, hazardous and petroleum assessments, brownfield investigations, and landfill investigations. And now I will go ahead and hand it over to Brantley.
Thank you, Ashley, for the introduction. And again, I would really like to thank everybody for showing up and for being here. Thank you again, Ashley, for organizing this, put it together, and thank you, Carus, for allowing me this opportunity to talk about this project. As Ashley said, I've got over 18 years experience in this industry. Been doing projects all over the Southeast. I mean, as far north as Virginia, as far west as Houston, Texas, and really excited to bring this opportunity in this project to talk about and show you guys. This project, we were using potassium permanganate to treat 17,000 tons of chlorinated impacted soils, and we treated it by in situ soil blending. A little bit about Exotec is we are a remediation contractor. We are the boots on the ground when it comes to working on your site and the remediation activities on it. We are not a consultant. I leave that up to you guys. I leave up dealing with the municipalities and the governing bodies up to y'all. Our experience, we have completed well over 200 injection and blending applications over more than 150 sites since 2006. We've been in business since 2005, but was incorporated in January of 2006. Most of the sites we've worked on are, of course, industrial RIC facilities, petroleum sites, dry cleaners. We have a lot of experience in brownfield projects, wood treatment facilities, and the list goes on and on. One thing about Exotec is our biggest thing is we offer a best fit solution tailored to your individual site. Some of the services we do provide are, of course, injection services. We do injections of chemical oxidation and chemical reductions, bioaugmentation, surfactant treatments. Soil blending, we both do in situ and ex situ soil blending. source area excavation, transport, and disposal, which of course most of those go hand in hand together. Environmental demolition is a phrase we've kind of coined, and that goes hand in hand with a lot of the brownfield projects we've been involved with, where there is underlying environmental concerns and things like either foundations or buildings need to be removed and disposed of properly. Also going along with that is concrete recycling and rock crushing. Here's some of the equipment that we do own and operate on a daily basis. On your left is, of course, one of our injection rigs. This one is specifically designed for larger volumes. With that rig, we have the capabilities of injecting close to 4,500 gallons in an 8-hour workday. We also have the capabilities of high pressure injections. And of course, like today, we'll be talking about the soil blendings and material crushers. In that picture right there was actually a brownfields project we did where it was a landfill that needed recap, but a lot of debris on top of it needed to be disposed of. Today, we'll be talking about a site in Crozet, Virginia. Crozet is about 20 minutes west of Charlottesville and about 90 miles west of Washington, D.C. Charlottesville is the home of the University of Virginia, so if we've got any University of Virginia grads here, we really like your town. The property itself is a 62-acre parcel, and of course it's bisected by a CSX rail line, and it is active, and you can see it right here. It was previously a office furniture manufacturing facility, and it operated from 1950 to 2001. And like most manufacturing facilities before the EPA was established, handling of chemicals was not a priority. So during the operations, subsurface contamination was caused mainly from the paint booth area with parts cleaning materials and of course the paint itself. In 2013 and 14, the entire building and all the structures on the property were demolished. So what you're actually seeing in this picture right now is just the concrete foundation itself. The chlorinated solvents from the operations, they were of course detected in the soils and groundwater. And some of the previous remedial activities on the site consisted of, soil vapor extraction system, and it ran for a little over a year, and it had some varying degrees of success. And some minor excavation and disposal of smaller source areas was performed on site, and you can actually see some of the areas where they cut the concrete and excavated and repatched. We were contracted by our client to treat an area that was approximately 175 by 75 foot in an area, and it's at the southern portion of the foundation. The vertical extent of the treatment goes from ground surface all the way down to 27 feet. And of course, that loosely converts to about 13,125 cubic yards. And the main contaminants concerned out there were tetrachloroethylene and some of its daughter products, with an average of 10 parts per million in the soils and a maximum concentration of 20. Like I said, we were contracted by our client. Now, this scope of work was defined by our client, and we were contracted to perform it. That's one of the things Exo Tech we do cover is kind of the whole spectrum of remedial plans. This one, we were contracted to implement the remedial scope, and then we do the other side of the spectrum where we can help you write your RAP or your CAP, depending on what state you're in, design it and implement it itself. The treatment methodology selected was, of course, in situ soil blending with using potassium permanganate. And the permanganate dosage was going to be divided up between the unsaturated zones and the saturated zones. In the unsaturated zones, it was going to be 6 grams per kilogram, and in the saturated zone, it was 10 grams per kilogram. And one interesting thing is after it was treated with the permanganate, Portland cement was added into the soils to help solidify the soils for purposes I'll cover in a bit. Potassium permanganate, like I said, was selected, and it is an inorganic compound with a purplish black crystalline. And when you dissolve it in water, it gives off an intensely purple or pink color. If you've ever dealt with potassium permanganate or sodium permanganate, you know what I'm talking about. Potassium permanganate was chosen due to its strong oxidation potential as well as its longevity once it's blended. Permanganate is also chosen because it does not require an activator, much like catalyzed hydrogen peroxide or sodium persulfate. So one of our things, like I said, we were approached by our client with their remedial scope, but they left it up to us to essentially write and design the plan of attack, if you will. So our plan of attack for the site was, first thing we were going to do is arrive on site and measure and mark out the actual treatment area itself. Once we did that, the concrete would be cut and then removed from the treatment area. And then with a size of a treatment area as big as this was, what we did is we divided up the treatment area into more manageable cells. The cells were measured out, and then we dosed the permanganate according to the size of the cell. The permanganate would be added dry, and while it's added dry, and during the blending process, we would add the water to achieve the proper moisture content. And then after we allow the permanganate to oxidize for at least a day, the Portland cement is added to solidify the treatment area. So the first step, of course, was the concrete cutting and removal. It was cut with a walk-behind saw, and it was cut into smaller pieces so we could, actually remove it and stockpile it. They were stockpiled on site, and then they were loaded up and taken to a concrete recycling facility. This is one of the things that a lot of people overlook, is the fact that in a lot of these states, the DOT authorizes using recycled concrete as a base for roads or asphalt. And luckily in Virginia, it is one of those states. So the concrete removal and disposal actually costs nothing to our client, because the certified concrete facility essentially took it off our hands for free. And you can see here an excellent slow motion video of the concrete saw in action. A lot of people think you can just fire this up and just let it do its work, but these things are actually kind of tough and hard to wrestle around. So after the concrete cutting happened and the removal took place, was excavation and stockpile of some of the treatment area. Of course, due to the size and depth of the treatment zone, some of the soils did have to be excavated and stockpiled actually on site. So what we did is we removed approximately a third of the treatment area and stockpiled it on top of 12 mil plastic, and then covered it with tarps and different things to basically, protect them from the elements. And up in Virginia, there are elements. And with the target depth being 27 feet, the blending process began at the deepest interval. So as I said before, a third of the soils were removed and stockpiled there on site. And then what we did is, it's kind of like a chess match when you're dealing with this size of a treatment zone. So what we did is excavated down to the lowest interval and took some of these soils, and most of the soils actually, and rearranged them inside the excavation. So that way, what that did is that prevented any kind of cross-contamination, it getting outside the excavation or on the concrete, and everything was, besides that 1/3, was contained within the actual excavation. So once we excavated and stockpiled and got down to the deepest interval, the next step was the permanganate introduction. And in this picture, you can actually see where the stockpiling happened. You can see how it's covered with an extremely large tarp. And then you can see the pallets of Portland cement that we used, and I'll discuss that later. So the potassium permanganate was delivered by the truckload in super sacks. The super sacks are weighing a metric ton, or 2,205 pounds. The permanganate was stored in a Connex box on site, and it was locked down. because due to the amount of the permanganate we would have on site, we had to register under the Chemical Facility Anti-Terrorism Standards, or CFATS. Now, CFATS is actually a division of the Cybersecurity and Infrastructure Security Agency. What CFATS does is it identifies and regulates high-risk facilities to ensure that there are security measures in place to reduce the risk of certain hazardous chemicals that can be quote unquote weaponized. And being 90 miles west of Washington, D.C., it's something that we had to do and had to follow through. So the permanganate, as I said before, the cells were measured so we could dose it according to the super sacks. What this did is it allowed us to measure the cells, of course, vertically and horizontally. So that way we would load the cells at a super sack rate. Most of the time what we did is we measured it to meet a single super sack. So what that did is it reduced any kind of field calculations and ensured that no chemical was wasting. So that way, instead of like, oh, we need to have one super sack and a third, to properly dose this cell, what it did is we would just dump one super sack in. And if you've ever dealt with super sacks, you really can't dump half a super sack. Once you open that valve at the bottom, it's coming out. So the permanganate, as you can see in the picture, was hoisted up by the excavator and spread across the cell evenly. And then once we did that, the blending process began. The blending consisted of directly mixing the chemicals into the impacted soils and groundwater. The blending head we used, which of course you can see in the picture, it spins at a rate between 50 and 80 RPM, depending on how you've got the throttle set on the excavator itself. But it's got a torque of over 19,000 foot-pounds. And the good thing about the soil blending itself and this specific head is you can change the head up to meet the lithology of your specific site. At this site, we had mostly clays. So we had, as you can see in the picture, those are called spade bits. They're a carbide bit, and what that does is it will disturb the clay and it won't gum up in and around the wheel. So once the permanganate was spread across the cell, that's when, of course, the blending commenced. The permanganate and the soils were blended together, and then the water was added after a little bit was, after the soils and permanganate were kind of blended dry together a little bit. Then the water was added to the desired moisture content. Blending of the soils would then continue until a good homogenized slurry was reached. As you can see in that picture, you can see how purple and pink it is, and we're still not done blending that specific cell. This was a video taken relatively early in the blending of that cell. As you can see, you've got some soils that are not quite pink or purple yet, and we haven't gotten to total depth yet. So during the blending, a lot of people ask, well, Brantley, how do you make sure that the entire treatment zone is covered? That's a good question. What we did is we overlapped each of the cells by approximately 1 foot, and that happened both vertically and horizontally. Because what you don't want to do is you don't want to have like ley lines of untreated soils that can potentially provide, later source areas. And how we did that is, if you can see in the picture, you can see some of these stakes sticking up. And what those would do is it kind of identified where the cell began and ended. And then also it takes a skilled operator to understand and feel the difference between untreated soils and treated soils, and also previously treated soils. So once each cell was completed, the soils were left to oxidize for, like I said, about a day before we moved on to the next step. The next step is, of course, the Portland cement addition. And with the size of the treatment area, treating each cell and not having the previously treated cells slough in or even being able to get on top of it posed an issue. Now, this was addressed before we even got on site, and we talked about it and discussed it. So to deal with that issue, we added a 6% by weight ratio of Portland cement into each treated cells. The Portland was blended in the same fashion. We used the blender to blend it in, and it was blended thoroughly. And then within 24 hours, the soils were stable enough that you could have heavy equipment on top of it. This picture is important, and it does show it because you see the excavator is sitting on top of a previously treated cell. So you can see how it's purple throughout there. And what it's doing is it's actually adding untreated soils, which you can kind of see to the left, into the next cell for treatment. So once all the treated soils, all the cells were treated, the final grade was constructed. And of course, with the addition of the permanganate and Portland, there was a slight elevation change because we added a bunch of Portland and a bunch of potassium permanganate. So to address that elevation, what we did is we actually created kind of a dome type elevation. And what that did is, of course, it prevented any pooling of rainwater. And then after that, we hydroseeded to prevent any of the erosion. Now, a lot of people jump in these things and, you know, they understand what I'm talking about, but they want to know the obstacles that we went through. And this one was actually pretty well thought out, and our plan of attack was pretty thorough in the addressing of the scope. So the main obstacle we dealt with was, of course, weather. It was absolutely nothing to go to bed one night and wake up to 10 inches of snow on the site. And of course, being in the mountains of Virginia, snow, rain, wind were an absolute constant battle. On the site, as you can see in the background on the left picture, is mountains, and then behind are mountains. So we were in the valley up there, and a constant wind of probably about 10 to 15 miles per hour was always on site. So to deal with the snow, of course, we had to get one of these little ride-on brooms to help kind of clear the site, clear the path, and it actually kind of helped us because we like clean sites and clean working environment. So the snow actually acted as a washing agent. The results of this project were, of course, following the treatment of everything, confirmatory samples were collected, and the results of the samples, everything came back below detectable levels. So we were quite happy and quite pleased with these results. Some of the keys to our success that we really kind of addressed to this site is the client did a very thorough delineation. They both vertical and horizontally, they knew exactly where the contamination was. We've done a lot of these blending projects where you end up actually kind of chasing contamination, especially on petroleum sites. The oxidant selection and dosage was absolutely correct on this one. We have sites where permanganate would not be the best selection because it's either petroleum constituents or other different varying reasons. And then, of course, the dosage, which worked hand in hand with Carus on selecting the dosage. And then the actual, of course, again, the plan of attack to address the scope. We did several site visits going up there to kind of address any unknown or unseen issues, because you can only see so much in a picture. But when you get out there and you walk the site and you kind of see, okay, well, there might be a footer underneath this concrete here. There might be, you know, some pipe or something here. And we were able to address that before we even set foot on site. Another thing is the thorough blending technique we use, making sure that you do spend your time blending the soils and making sure it's very homogenized. And then last thing, being flexible, not only on our end, but our client's end. As I talked about the Portland cement, we dosed it at a 6% rate, but originally it was supposed to be a 3% rate. But after we started blending treating the first cell with the Portland, it wasn't setting up enough. So we were flexible enough, and our client was flexible enough to approve and the increase from the 3 to 6%. And that is actually it. So thank you guys for your time. You can contact us at the information on your screen at 770-207-0222. You can shoot me an email, or you can actually go to our website at exotecinc.com. So any questions?
Perfect. Thanks, Brantley. We do have a couple that came in. The first one is, why was permanganate selected over different oxidants?
Like I said before, the permanganate was selected because of its strong oxidation potential and its success rate that we've seen, especially with chlorinated solvents. One of the main reasons also is the fact that it didn't require any kind of activators. Whereas if you were using persulfate, which is a very strong oxidizer, it needs an activator. So what that would have done is increase the blending time, because one of the activators we've used with persulfate is hydrated lime. So you've got to blend in the hydrated lime and then come back and blend in your persulfate. So it really increases and or doubles the time that you're actually handling the soils.
Okay, and were confirmation samples collected from via excavator bucket as the work progressed, or were they collected via cores?
That is a good question. It was actually done through both. They would collect them off of the excavator bucket just to ensure that, it was getting dosed properly. And then they also collected them later at a later date to confirm everything.
Alrighty, next one. How do you know that you got representative samples, and did you have to quench the permanganate reaction during the analysis?
So the permanganate, you can really see if the permanganate is quenched, because you can visibly see it. And what was the first part of that question?
How do you know that that you got representative samples?
They followed the ASTM standards as far as sidewalls, floors, and then of course the per cubic yard rate. So they went through and just grabbed it throughout the excavation, like I said, through cores, and submitted those so they could have a full representative sample of the site.
It looks like we have one more. Was this site enrolled in DEQ program? And if so, what program?
I do know it was part of the DEQ. I don't know exactly which program it was in. I think it might have been Brownfield.
What is the desired moisture content?
That is a really good question. And that is going to be depending on your soil lithology itself and upon what actual oxidant you're using. We like to reach kind of a peanut butter-like consistency. So it's floating around like a 75% moisture content, if not more. Like I said, I mean, it's more of a visual inspection. You can really see when you need to add more water or you need to add more oxidant. But like I said, we kind of like to get it at a good peanut butter consistency.
Okay, and another question just came in. How did you get down to 27 feet? I thought mixing was limited to about 20 feet.
That is another excellent question. How we did that is let me see if I can actually go back to the slide. There we go. So you can see the treatment area, and it was rectangular in shape and everything. If you can visualize, like I said, it's like a chess match. You've got cells both horizontally and vertically. So what we did is we excavated, like I said, a third of the treatment area, and then we if we didn't bench it down, what we did is we sloped it down and then got to about a depth of probably about 18 feet is where the bottom of the excavator was sitting. And then that allowed the excavator itself to reach the depths of 27 feet below grade. But like I said, if you can imagine, what we did is we kind of went, actually at the southernmost extent is where we started, this way, and sloped it from the north being the highest elevation to the south being the lowest elevation. And then, like I said, we just kind of moved the soils inside the excavation around, so we didn't have to continue to take soils out and then bring soils back in. But that's what we did. We sloped it down into the excavation.
Okay, and how long did the permanganate persist after mixing? Did it go away during the mixing event, or was there leftover purple?
There was a little leftover purple in some of the areas, but for the most part, the purple was actually gone within like 12 hours. You could see the purple really just, it was gone, and I mean, other than, like I said, other than a few little spots, it was pretty much gone.
Okay. What did you do to confirm lateral and vertical cell depth? Survey, GPS?
So survey. What we would do is, of course, we would cut, the treatment area was cut, and then we were lucky enough that this was a concrete foundation. So utilizing basically like a TopCon survey pole and stick, we were able to, shoot it and measure the depths. And that's the easiest way to do it. Like I said, the first thing we did do when we got on site for the actual project was we did work and, hand in hand with the client. And, like I said, you can actually see in this picture some of the boreholes actually going through, and they did a phenomenal job of delineating it. So, and what you can't see is the spray paint marks of the previous samples, but we worked hand in hand with them, measuring out absolutely everything and then marking it with paint.
All right. Does the cement stabilization impact analytical results?
No. I know a lot of, like, if you were putting it in a VOA vial that was that has hydrochloric acid, you'll get bubbles, but no, it did not mess with the analytical results.
And how long did the soil blending take?
So from the day we actually got on site to finishing this treatment area, I believe it was just over 3 months, and we adhered to a 10 days on, 4 days off. That was a schedule written out by our client. They wanted to work 10 days and then off for 4 days. So, and then of course they wanted us, and this never fails, and I love it. When we go do these big projects like this, and we always joke about if there's a drought, then hire Exotec to do some soil handling project, because when that happens, we'll have record-breaking rainfall. So, and of course, during this project, we did have record-breaking snowfall.
Yes. Okay. It looks like we have one last question. How did you deal with health and safety given the high VOC concentrations?
So the health and safety, of course, nobody was, I mean, if you were touching the dirt or anything, you had to be wearing, of course, your standard PPE. And then actually when you're in an excavator, we had monitors in the excavators, and if needed, we had PAPRs, or positive air purifying respirators, that would filter out inorganic or organic vapors. And that's a good question, because that's one thing Exotec really just abides by, is the health and safety our clients and our personnel.
All right, I think that's it for the questions. Thank you, Brantley, for presenting today, and thank you everyone for joining. Have a great day.
Thank you very much, Ashley.